Halevai is a new concept boat manufacturer focused on engineering, design, innovation, and conservation. The electric boat maker is leading the movement to 100% clean energy design solutions for all marine watercraft by 2050. With me is Frank Heidinger, the founder and CEO. Great to have you here to hear about the company. Let's just start with a broad vision. What's the mission of Halevai?
So the mission is to slowly work towards this 2050 goal set by the UN back in COP21, which is to reach a net zero facility. So when we look at what boats are made of today, fiberglass, polyresins, even the best made boats are made from not great materials. And so we started with the power, the energy production, and we started to build more renewable solutions. So as our grid becomes more renewable, which is happening at a rate that changes, Europe is at 20%, US right now is at 12%, but these rates are going to grow towards 2050. So every time you plug in, you'll be using more renewable energy.
Okay, so they're electric powered.
Fully electric powered.
And what are they made of?
The batteries are lithium iron phosphate.
But what about the boat itself?
The boat's a fiberglass boat.
Oh, it's still fiberglass. Okay.
Yeah, it's a fiberglass boat. And so this is the 2050 goal, right? Is to start with power, which is something that's attainable right now. It's at a pretty good price point currently. Okay. As you know, electrification's growing at an enormous rate, both for micromobility and now onto the watercraft segment.
Okay, and I was interested to see all the boats are made in the U.S.
Everything's made in the U.S.
Yeah.
So
Where
fully
do you make
designed.
them?
So we build our prototypes in Indiana. We're going into a longer full-scale production in White Bluff, Tennessee.
Okay.
This is a really interesting move for us too, because most American boats are built in the U.S. So most recreational boats that are currently built, and we didn't want to change that. It would be a shame to build a renewable energy solution and then be importing it from another place.
Right, and use all the energy to get it here.
Correct,
so.
exactly right.
And I'm from Indiana, so I'm glad to hear.
All right,
that you're
we were in Seymour, Indiana for 3 years, building prototypes, testing prototypes on those waters.
Yeah. So what are the logistics? If someone buys one of these boats, are they able to charge it at home? How is the infrastructure around electric boating?
So when we look at the infrastructure of charging boats, it's a little bit different than the road, because people typically use boats for shorter periods of time for recreation, and so they have more time to charge them. So the supercharging desire or the need for supercharging isn't really there. These boats can charge on what's called the JL1772, which is your standard phase 1 or phase 2 car charger. This is what you buy on Walmart.com. This is what you buy from Amazon. You get a phase 1 or phase 2 charger, and they can plug in anywhere. So if you have a 110 available, it'll charge at a rate of 3 kilowatts per hour. If you have 240 available in your garage or at your shore power at your marina, or if you have a dock and you want to charge from your pedestal, 240 charges around 8 kilowatts per hour. So your charging times range between 4 and 12 hours, depending on the current you have available, but there can be plugged into any outlet. So the same place you charge your iPhone, you can charge your boat. Okay,
very interesting. And you could do it overnight and, when you're done boating for the day.
Well, that's the model, right? Yeah. The use case is typically 20 to 30 nautical miles in a day at the top end of recreation. When you're dealing with lakes and rivers and waterways and tidal estuaries and bays like the Biscayne Bay, for example, where we operate our boat often, you're using 20 to 30 nautical miles of charge. So you're talking about 50% of your batteries being used in that day. To recoup that, it'll take a few hours.
Okay, interesting. Well, I was going to ask about the range. So like average use time, or even sounds like the higher end use time, will last you a full day.
Yeah, so range is a really interesting topic for electric propulsion on water, because what a lot of the other groups are doing is starting with the traditional V-hull or displacement hull, which requires an enormous amount of energy to get on plane. What we've done is we've simplified that, and we went to a semi-planing hull called a trimaran. And with that, there's a lot less resistance, and so you can get up on plane and use a lot less power and therefore extend your range.
Now, do you have different boats? Are there boats for speed, boats for leisure?
So all of our boats are built off the same hull, but we have 3 deck configurations. So we have a deck configuration, which is a center console, which is featured on our website. We have a split console production model that's being built now and will be offered by 2025. And we also have what we call our ERV, which is a research vessel for institutions, for NGOs that are doing research in these waterways. There's really no use for gas anymore. If you're doing short range scientific research, it's really silly to be using gas to do that research. And for more institutional or municipality use, a lot of these boats don't move a great distance, but they sit on idle for hours and hours. And so if you're using electric power, you're not wasting any, there's no output, To sit on idle, you use very little power. Whereas gas motors are still idling at 600 RPMs, and so they're burning gas 24 hours a day in most of these cases.
That polluting.
Net. When you start to think about that
Uh-huh.
nationwide, it's a really big number.
For sure, yeah. Now you mentioned municipalities. Would governments be a potential customer?
Yeah, so we're actually working with local municipalities. So some of these municipalities are direct government agencies. Some of them are affiliate programs where a particular waterway is monitored by an NGO, but they're being given validity through the government. For military application, it's really not something viable, but for marina monitoring, for coastline protection, for safety and security purposes, for patrolling short distances on lakes, for example, and rivers, just to make sure that people are following rules. And these types of boats are a big market for us.
Yeah. Can I water ski behind the boat?
You sure can.
Okay.
Yeah, so there's a lot of torque on these boats. So that's the one nice thing about electrification is that you get that torque. And so you go from 6 knots, which is what you'd call, a no-wake zone speed, to 20 knots rather quickly.
Yeah, and the name of the company is
Halevai.
significant. Yeah, explain that.
Yeah, so it's an odd name, and that's why we liked it so much, because it has so much history. This is a word that's 6,000 or 8,000 years old. It's been used in a very optimistic way. So it essentially is something that we all understand, and we see it. We're driving along the road, and we have these moments where we go into like a meditation, and we see the future, and we don't know how we're going to get there. This sort of will for it to be, or if only it could be. Often Jewish grandmothers would say this to their kids or something. They'd say, Halevai, if only it could be, right? Yeah. And so we thought this is a beautiful energy to bring into the spirit of innovation and design that we're bringing to the boating industry.
Yeah, and kind of the peacefulness of boating too.
And we see the future being very differently. It's going to take generations to get there. That's why we named the first model the Model 50. Because the idea was the Model 2050 is built towards the goals of 2050. So we know we can't change all of these things today. We can definitely change power. We can change the renewability of our grid. We're also going to change the material development we're working on. Interesting programs where we're developing new materials, biotechnologies, nanotechnologies that can be applied to the actual physical structures of boats. And the batteries themselves are going to develop over time too.
Yeah. Interesting. And you have some partners as well.
I do. We have one. I have one partner. His name's Brian Vetter. He is the builder of a Tessie Mays, which is a organic salad dressing company that's been, finding its way into all of the shelves of Whole Foods and Sam's Club, and he's been really helpful in helping us get from 0 to multiple units, right? So 0 to 1 is the easy part. You innovate, takes a few years, it's slow going, and then you have to get from 0 to scale. You have to scale.
Yeah.
And this is where Brian's been really helpful with bringing his knowledge of scaling nationally to our team.
Yeah. Now, what about the supply chain, the building of it? Is that clean? Are you working toward that?
Yeah. So our batteries are typically made overseas, as are most lithium-ion batteries. But the supply chain on that has a CSR standard, which is pretty high. So anything coming into this country is documented, and there's agencies that double and triple check this stuff. As far as the building process, we're using an infusion molding process, which limits waste. It's the cleanest system that you can build a structure because you don't use as much material and there's not as much waste in the process. And so the supply chain for us is going to only get better. And that's the thing about scale, is that often in the early days of any scale production, it's the dirtiest. And then when you get further into the process, it gets cleaner and cleaner. But a lot of our stuff is handled internally in the United States, and those processes are very clean.
Yeah. Are the boats available now?
They are, yeah. We're selling. We are building up our delivery schedule for later this year. We're taking orders through 2025. Again, we are scaling into this growth. So we have institutional clients, we have first-time beta clients, and our website's a good place to come visit us and learn information and schedule a demo ride. Come down and see us and get on the boat. And
that sounds
the
awesome.
ease of operation is really what changes. You have a silent entry. You get on board and you start the motor and you don't really hear anything. And they're really balanced and easy to use. And we see people going, oh, really? I could do that. That's easy. That's approachable.
Yeah.
And that's the thing about technology, is that you're doing the same thing, but the way you do it is a little bit different. And it tends to be a little bit more approachable and cleaner, and it feels better.
Well, the noise pollution. either.
Right. I mean,
which
our
could have-
motors do make some noise at speed, but most of it is water noise. It's interesting. We have our motors make some noise in the lower RPM operations, and as you start to go faster, the noise disappears. But the ease of operation, there's a keyless entry. There's no sound startup. It's pretty much plug in, pull out, and have an adventure. It's a bit of a discovery for everyone involved.
And what's the price range?
So our base models are at $185,000 for 24-foot boat, carries 10 people. That range is between 40 and 50 nautical miles. We also have extended range packages, which, like anything in the boating world, you start with a base model and it's really up to the customer to configure navigation, lighting, decking, components. And these things are expensive. So, it's at the user's bequest, right? If the user wants it, they can add it on, we can provide it. But the base model is $185,000.
Okay, and so what's the future? What's your kind of goal in the near term?
Well, so the goal now is to work on battery density modifications and get longer and longer ranges by tweaking the programming of our VCU. This is, for us, the biggest thing, right? So the hull we chose is super efficient. It's 2 to 3x efficient on anyone else in the category. Now it's about figuring out what's that programming look like.
Okay, Frank, thank you so much.
Oh,
It was
thanks for
great
having
to
me.
hear about the company.
I appreciate it.
Thank you.